Now, what is work? In terms of physics, work is done when a force is applied to an object and it moves. So work done is a product of force times the distance moves parallel to the force. So basically the definition of work should be force times distance. However, this is not correct. Work is defined by force times displacement. The unit of work are Newton meters or joules. Basically, if a 1 Newton force causes an object to move 1 meter, then 1 joule of work has been done. Note, we are saying here that the work is done as a product of the force applied to an object times the distance the object moves parallel to the applied force. It goes to reason that the car and Indy 500 do no work since they start and end at the same point. Please note that the work is not an intrinsic property of an object. You cannot say that a body gains or loses a certain amount of work. Work is simply a force that is acting on a body and it moves through a certain distance. Work done in raising a body. The work done in moving a body to a height h against the force of gravity is going to be given by work equals force times the displacement, the height that it moves up to. In this case, since this is work done against the force of gravity, it is going to be given by mg. And then the height can be replaced by h. So the total work done in moving an object against the force of gravity is going to be mgh. The interesting thing is, if mass and height are the same, the work done depends on the gravitational pull. So in this case, if we were to consider the work done on Earth, it will depend on the gravitational force on Earth, which we know to be 9.8 meters per second squared. If the work was done on the Moon, the gravitational pull on the Moon is 1.62 meters per second. So the same height, which is 10 meters, 10 kilogram object to go up by that height is going to be 1/6. The work required to move it will be 1/6 that of the work on Earth. The work on Mars is going to be 10 kilograms, same mass, but the acceleration due to gravity is 3.8 meters per second squared times 10 meters, which is a height, equals 1/3 the work done on Earth. So basically, the work done in raising a body depends on the object that you are interacting with. Interesting features for work are work done equals 0, which will mean that when we say that work done is 0, it will imply that either F, which is the force applied, is equals to 0, or when displacement equals to 0, implies that the work to be done, there must be a change in the position. So like imagine if you got up from bed in the morning, you did work all day long, and at the end of the night, you went back to sleep, you have done no work because your displacement is 0. Also, the work will depend on the angle applied. When angle equals 0, work equals force times displacement. When angle equals 90, there is no work done. When angle equals 180, work is the negative work. For example, raising up the mass against gravitational force through a distance h will actually be a negative work. Another very important concept for physicists is energies and types of energies. What is energy? Energy is defined as the ability to do work. Work and energy seem very much like the same thing. When the net force is applied to an object, it undergoes an acceleration in the direction of the applied force. If the force continues to be applied, the velocity of the object will keep increasing. The effect of an applied force on an object is to increase or decrease its velocity, say from velocity 1 to velocity 2, keeping in mind that this change of velocity depends on the direction of the applied force. So, in other words, we can write that the net work done on an object is equals to the change in kinetic energy of that object. And kinetic energy is always given by half mv squared, where m is the mass of the object and v is the velocity of the object. So the net work is equals to the change in kinetic energy is simply known as the work-energy relationship. The definition of a work-energy relationship is the net work done on an object by an applied force is equals to the change in kinetic energy of the object. Now remember, we were talking about the different types of energy. So energy units are joules again. So there are mainly two main categories in which we define energy: kinetic or potential. Kinetic energy is the energy due to the motion of an object. For example, the ball hitting the bat. So the ball will have kinetic energy. Potential energy is the stored energy in the object that allows that object to do work. So the potential energies could be of different types. It could be due to the height of an object, it could be due to fluid pressure, it could be due to a compressed spring, or it could be due to the tension in the string. So when we talk about potential energies due to height, the formula is mgh, as we saw before. Fluid pressure, and the formula is going to be 1/2 Vp squared over P naught, where V is the volume, P is the pressure, and P0 is the atmospheric pressure. Potential energy due to a compressed spring is going to be 1/2 Ky squared, where K is the spring constant and Y is the displacement. Due to the tension in the string will be 2Ty squared over L, where T is the tension, Y is the displacement, and L is the length of the string.